Welcome you all. Today we are going to see about page replacement algorithm, which one is the most important concept in memory management techniques in operating system. Before you enter into the topic, you subscribe this Charan Media's channel for the future reference and click the bell button for the further notification. Let us start. See the first point. Generally, program must be brought into the memory for the execution. It is a key point in the memory management technique. If the page is already present in the memory means no issues, it will execute. Suppose if the page which is needed to execute is not present in the memory means the page fault will occur. The page is not present means the page fault will occur. So from this we can know that page fault occur means we have to go for the page replacement algorithm. We will see the definition for the page replacement. See the first point. Page replacement is a technique that finding some page in memory but not really in use, swap it out. We can clearly know that page replacement is one of the technique. Okay, we have to find the free space. Suppose that free space is not present means we have to find a page to replace. This technique is represented as the page replacement. To do the page replacement technique, we need some page replacement algorithms which will result in minimum number of page faults. Let us see the three types of page replacement algorithms. First one is first in first out, second optimal, third one is least recently used. Let us see the first in first out page replacement algorithm. FIFO is an acronym for first in first out. See the first point. The simplest and low overhead page replacement algorithm is a first in first out algorithm. From this we can know it is a simplest method. Let us see the first in first out page replacement algorithm with an example problem. Here one problem is given. In this problem 20 pages are given as the input. They also represented as we have to take only 3 frames to store these pages. At the initial stage these frames are empty. This is the input given. Let us start. The first page is 7. The frames is empty. So we will insert the 7 into the frames. So page fault occurs and the 7 is inserted into the frames. Next 0. There are 2 free frames. So we can insert also 0. Next 1. We have 1 free frame. So here page fault occurs, we will insert 1. Next we want to execute the page 2. But in the frames 701 is present. So there is no free frame. So we want to replace. Here only we have to use the page replacement algorithm. First in first out. The page 7 is comes first. So that frame is replaced by the 2. So we get 201. Okay. Next the page we want to execute is 0. But the 0 is already present in the frames. So there is no page fault. So we go for the next execution. Next execution is 3. The page 3 is inserted into the memory. But already we have 3 frames 201. So we have to replace any one of these with the page of 3. So the second first in first out, the second page came is 0. So 0 is replaced with 3. Next we want to execute 0. Out of the 3 pages, 1 is the next one. So 1 is replaced with 0. I think you are clear with the concept. Okay, next we will proceed. The next page we want to execute is 4. Already in the frames 2, 3, 0 are present. Out of these 3, 2 comes first. So 2 is replaced with 4. Next execution we want to execute 2. Out of these 4, 3, 0, next 3 is comes first. We don't consider the 0. So 3 is replaced with the 2. Next page 3. If we want to insert 3 means we have to replace 4 to 0 any one page. Next page we have to consider is 0. So 0 is replaced with 3. the output is 423. The same technique is repeated for the continuous pages. Okay, let us clear. Now the current position is in the frames there are 3 pages are present, 4, 2, 3. Okay. Next page we want to execute is 0. Okay, that's also clear. See the crashed numbers. Next we want to replace the number is 4 because up to 0 it crashed. So next page we want to replace is 4. Okay, comes to the page. Next page we want to execute is 0. So 0 is replaced in the place of 4. Okay, next page we want to execute is 3. 3 is already present in the memory, so no page fault. Next page we want to execute is 2, that also present in the main memory, so there is no page fault. So next page we want to execute is 1. Okay, already in frames there are 3 pages is there, 0, 2, 3. So next page we want to replace is 2, so 2 is replaced with 1. Let us continue. The next page we want to execute is 2. No doubt in this. Now we have 3 pages in the frames 0, 1, 3. Okay. We have to replace with these 3 numbers, any one of these 3 numbers with 2. Okay. Next number we want to replace is, see the above crashed numbers, 3 is there. So 3 is replaced with 2. So we get the next frame list 0, 1, 2. Next element we want to execute is 0, that is already present, so there is no page fault. And next page we want to execute is 1, that also present in the memory, so there is no page fault. Next element is 7. We want to execute 7 means we have to bring that page 7 into the memory. Already we have no free frames, 0, 1, 2 is present in the memory. So out of these 3 pages we have to replace any one page. So see the crashed numbers. Next without crashing is 0. So 0 is replaced with 7. We got the output as 7, 1, 2. Next, the next element which is executed is 0. So we have to replace. So next, see the crashed number. Next element we want to replace is 1 because we won't consider 3 and 2. The next element 1 is replaced with 0. So the output is 702. The last page we want to execute is 1. 1 is replaced with 2 because see the crashed number. So the final output we got is 701. Out of these 20 pages, there is in some of the place page faults occurs. In some of the places no page faults. So at last we have to count the number of page faults. With the help of first in first out page replacement algorithm, we have to count the number of page faults and finally we have to give the output. Here we will count, there are 15 page faults occurs. The final output is 15 page faults occurs in the first in first out page replacement algorithm for these 20 pages when we are using 3 frames as the memory space.